Coming up on this episode of Change Mode, we talk about responsibility, segregation, and the Liskov substitution principle. It's an exciting episode of Change Mode, and it's coming up next. This is Change Mode, filmed on January 14th, 2015, episode number 10, Solid, Built Ford Tough. Hello and welcome to another exciting episode of Change Mode. My name's Dan Miller. That smiling guy over there is Colby Rabideau. We're here to talk to you about Solid. Before we get to what that is or anything about it, remind you to go to coffeeandbeer.tv or our super cool vanity domain name, changemo.de. Change Mode with a fancy German, or is that Denmark? I think it's German. Germany TLD. So this week we're going to talk about Solid. Before we do that, Colby, is there anything you want to get off your chest? Any computer stuff you want to talk about? Some like eventual consistent data stores or something like that?
Oh, that happened to me today. So at work we have so I guess we keep like our important like data. So this is the way it was explained to me.
Okay.
We keep our customers' data in MySQL.
Yep.
And then we keep our customers
the reliable database of choice of companies all over the world.
Right. And then we keep and then our customers' data, which is like exponentially larger than our data, is we keep in HBase, and like we use like Elasticsearch for like querying basically. So like our all of our like rich querying functionality is built on top of Elasticsearch. But consequently, our like when you make changes, like when you associate certain objects with other things, there's a normally small, when everything's running smoothly, like time penalty for the change. So like, you know, you write something to an API and the request comes back. If you immediately go and query Elasticsearch, it will not necessarily have updated yet.
Elasticsearch
today
is indexing data it gets from HBase.
Right. As far as I understand.
It hasn't indexed it yet.
Right. Yeah. Yeah. So basically, there's like a queue. There's a queue of changes, and there are a bunch of workers that like index things off those queues. But that operation is asynchronous. So
right.
when I wrote to the server and then refetched my thing, it was the same as it was before I wrote, and I was confused. I was a little confused.
Are you upset?
I mean, I was more upset at myself that I forgot, like that I didn't realize it sooner, and I spent a bunch of time being like, "What is going on?" So like I thought I was doing something wrong, and really I wasn't. But
so I have a thing I need to get off my chest. It's sort of interesting. Have you heard of ulimits before in Linux?
No, I haven't.
Each process has a set of limits associated with it, there are memory limits and all these things you can set on a process ID basis.
Yeah.
One of them is the number of open file descriptors it can have.
You know, I have heard of ulimits because there was something that you use on the Mac that doesn't work if you don't up the ulimit on your Mac. I don't remember what it is. Anyways, continue.
Yep, that's ulimits, and we're moving from Apache to HHVM. Apache starts one process for each worker node that will be handling requests, which means that it gets its own ulimit. So we were switching to HHVM, and suddenly HHVM, we moved to these super new beefy 32-core boxes from our old testing 16, and suddenly it crashes about once a day saying it's run out of file descriptors. And our immediate thought was, oh, there's a file descriptor leak somewhere. It's not closing the files, and we got to go track down and see what it's doing. The first thing is file descriptors are aptly named, but also confusingly named because you use a file descriptor to talk to another host over the network because a port, a socket, is just a file, so you open it and you write bytes to it and stuff. So we weren't actually running out of file descriptors. We were running out of. We were spending all of our file descriptors on network stuff. But even still, we were like, okay, why would this be a problem in HHVM and not a problem in Apache? And it's because each Apache worker is its own process. The HHVM workers are threads, so all the HHVM threads are under one process with a 1024 file descriptor limit. And when you have 50 databases and 50 Memcache servers and 32 worker threads, you're already at like 600. So that was some hours.
Nice. So what did you do? Just increase?
Oh, you can just increase it.
Nice.
Yeah.
I like that. I like when that's the solution.
Well, I asked why it's there in the first place because I didn't know, and apparently it's usually a good idea because there is a global limit, and you don't want one process to be able to use all of them. Another nice side effect is it saves you from having a process that kind of fork bombs and not fork bomb necessarily, but starts recursively, infinitely opening and writing all these files to disk and never closing them, which could like fill up your file system and cause have you ever had a Linux server with no space left on disk? It's not fun.
No, I take that back. Yeah, I have. The at Facebook, the shared dev servers would routinely run out of disk space because certain people would have like 50 plus gigabyte, like I don't know what they had in their home directory, but routinely, and the most fascinating things would stop working.
Right? Yeah, it's so many things have to write to disk in order to work at all.
Yeah,
which is amazing.
Yep.
All right, should we talk about some solid, some object-oriented design?
Yeah, I think so.
Okay, so this was sort of a joint episode topic. So the first thing we're going to call this episode Solid. We should talk about what Solid is, and we have some definitions over here. Definitions. Okay, so
should we talk? Is it safe to assume that everyone knows what object-oriented programming is?
I think so. You can give a quick recap if you want to, though.
I see. This is interesting because I'm not sure I can explain it.
Alan would be very upset. This was on every test in all of his classes.
Really?
What are the 3 principles of object-oriented design?
Oh, I can do this. Encapsulation. This was on Helen Hayes' tests too.
Mm-hmm.
This is like, oh man, polymorphism. When you have a really, really wealthy relative that you didn't even know existed who suddenly passes away and gives you a great big inheritance.
Yeah, there we go. Encapsulation, polymorphism, and inheritance. I guess we can start talking about this now. I have come to realize that I don't care about any of those except encapsulation. I used to care about inheritance. Now I don't think I do. We can talk more about that later.
Mm-hmm.
Encapsulation is my favorite. Encapsulation gets you all of the things. It gets you maintainability and extensibility, more easy to reason about code. And as a result of that, I think that Erlang is the most OO programming language out there. The most purest OO programming language.
That's probably true.
Because in Erlang, you have these lightweight processes, these Erlang processes. They have a defined interface that you can talk to them with, and they share nothing with anything else. They're fully encapsulated, and you have to talk to them through these methods that they have. Basically, there's no way to reach in and change local variables. You can't change any of the state. I like that a lot, and when I write OO code in any programming language now, I try to make it like Erlang.
Interesting. See, so I've been starting to think that. So I'm not sure if this counts as encapsulation, but I'm inclined to say that like data encapsulation is only necessitated by immutability.
By mutability.
Yes. Sorry. Thank you.
Yeah.
And like without mutability, you don't need data encapsulation.
The Boston TV weather folks.
And I don't know. If you don't have it, you don't need it anymore. So maybe it's not necessary at all. That being said, I think like encapsulation applies to other things like behaviors. But I don't know. Maybe it doesn't. In the OO sense, I don't think it does. Because in the OO sense, I think it's like that very much refers to data and private state.
One of the experiences I've had that caused me to rethink everything I thought I knew about OO is I sit across from this person at work who hates OO. Hates Java is like the root cause of this, and Java is terrible. Mm-hmm. I'm just kidding. Not really. So he writes all of his code as public static functions. Everything is a public static function, vaguely encapsulated in these modules that are classes, namespaced basically. And if you told an OO person to do that, they would, oh, that's terrible. That would be awful. Like, think of all these things you're losing. But you don't lose that much in my estimation. And what you gain, you lose the ability to test things at all because static methods are dumb. So there's probably a better way to do this. But what you gain is it's so easy to understand what's going on. And that's one of the big downsides of a heavily OO system is it's really difficult to change the code because you don't even know where the functionality is that you want to change. And this is especially, and it's ironic, I think it's made easier in languages like Java that have this culture of IDEs and a rich metadata around the code.
Right.
But when you lift that out and take it into Ruby or PHP where there is no really an IDE and there are debuggers, but they're, you have to like jury rig them in with Xdebug or something like that. It's not easy at all to discover where different parts of the code are. So I've been working, last year I worked on a project that was pretty much two things. I was working with someone, we did full OO, and then we were sort of working with this other team that was providing the API. The API that we were using was written entirely in this public static method, and we were doing entirely OO. And I would say a year later, their code is easier to understand than our code is. And I don't think the maintainability is all that different. But I see some downsides, but they might be theoretical, and we'll talk about that when we get into Solid.
Cool. So, but I mean, like, I don't know, if anyone doesn't know, that's fascinating. For one, you should write into the show. I would love to talk to you about how you've managed to do programming.
How you managed to find this podcast and not know what OO is.
Yeah. Not to say that it's a bad thing. Like, good for you, but it's just fascinating. I feel like Java is like Java or C++ or something are like probably the go-tos for any sort of like CS curriculum, and
which is bad. It's what is it like? It's like cargo culting. I think in a lot of ways, we did this like C and sort of OO C++, but it was kind of bolted on thing, and then we were like, oh, Java will save us. It will tell us everything to do. Everyone's going to do that. That's the future. That's, clearly how it should be. And I don't think we're anywhere near knowing how to do any of this stuff. And there's a whole industry around OO. There are books written about OO. There are OO consultants and all of these people who are invested in making sure that people write object-oriented code for the long haul, which is fascinating.
Yeah.
We think that we are very meritocratic and logical here in programming land, but There are businesses who make it their mission to make sure people do OO. So couple that with like the education of everyone learns OO first for the most part, and we're blinded to its downfalls in a lot of ways, I think.
Yeah. Yeah. I think like having that sort of mindset be many people's intro to how I don't know, like how programming works, like that their intro to systems thinking makes things tough. Like it makes it hard. It's really hard. Like I don't know, how long have I been at this, Dan? Like 3 or 4 months. Like I've been like learning or trying to learn Clojure, and I'm really bad at it. It was really hard. It is like a struggle for me to write. Mm-hmm. Like I'm getting better at the basic stuff. Like I can do math without a hitch, but like the more advanced, like putting together more advanced constructs is tough. And it's like it's because my brain, like I've trained myself. I haven't trained myself to think in that different way yet, and it's pretty tough. Yeah. But anyways, I think we should talk about Solid.
Okay. So I think I probably introduced Colby to Solid. I watched this amazing talk by Jim Weirich, the late Jim Weirich, sadly, on Solid programming. I had no idea what it was, never heard of it. And he kind of goes into the history. I think Bob Martin, also known as Uncle Bob, coined this term in the Java community, and it's an acronym that stands for the single responsibility principle, the open-close principle, the Liskov substitution principle, which is the craziest sounding one, the interface segregation principle, and the dependency inversion principle, which I always call the dependency injection principle, but that's not what it is. Dependency injection is a totally different thing. So we just want to start from the top down?
Yeah, let's do it.
Okay. The single responsibility principle. This is one of the ones that I disagree with, I think. So the single responsibility principle says a class should have one and only one reason to change. So, for example, if you have, the example given in Jim Weirich's talk is if you have a part of your code that parses command line options and then also is responsible for storing the parsed data. So you imagine you might keep a hash map of like the configuration of the program, like, oh, well, our path is, they told us to look in this folder, and this option is true, and this option is false. You might store that all in that class. Mm-hmm. That would be a violation of the single responsibility principle in these people's minds because the class is parsing and storing. So one of the things they say in this talk is, if you want to know if you're violating the single responsibility principle, describe your class, write down the description, and if you have to use the words and or, it probably does too much. So what you would do in this case is separate this out into two classes that are instantiated and talk to each other. You'd have like a command line parser class and an option storage class. What do you think about the single responsibility principle, Colby?
So I'm interested to hear like what your reason for disagreeing with it is. Mm-hmm. But I guess practically speaking, I think it's a little utopian. Like like I think, I don't know, to actually do it seems pretty hard. That being said, it does. I could imagine how it is desirable. I also like I don't know if I ever saw it worded like the definition of this single responsibility principle worded that way. Like it should only have one reason to change. I think I've always in my mind I've always thought of it as it should only do one thing. But
well, right, that's a simplified, like, if you have to use and or to describe your class, then it's doing more than one thing.
Right. Yeah.
So, reason to change, I don't think that's about data encapsulation. I don't think that's talking about the internal representation of that
Hmm.
class's state. I think it's talking about the
Like,
code
right.
that's
Yeah,
in that class.
that was the sense because right before this, I've never seen Jim Weirich's talk. So I watched some of it, but that's the sense that I got.
Right. Yep. So the reason I disagree with this is one of the reasons I think that really abstract OO code is difficult to read is because two bits of functionality that are very closely related could be in entirely different files. And this is a failure of our tooling that this matters at all, that we care about files at all. This is like the small talk, what it rebels against, and a couple of other of these languages that we even have files. Java rebels against this in some ways with its package notion, but keeps the files around anyways. In classic Java, well, we're going to make it kind of difficult to understand and also not give you any of the benefits of the abstraction. Like with all of it abstracts you away. It doesn't. If you're writing Java in Unix, you don't have access to any of the Unix utilities, but the abstractions do use them. So you have to know what they are anyways, and how. It's terrible. So if you have in that example given where oh well, the command line options are parsed and then stored in the same class, that's a violation. It's only a violation if it becomes a problem in my mind. If you want to use the either of those things independent from the other, then yes, it's a problem. But if you don't want to use, then I say the optimization is better to keep them together for maintainability. And maintainability is not just like infinite change. And I think a lot of people think maintainability is I should be able to change everything everywhere as fast as I want to, and like the time it should take me to make those changes should be very small. But that leaves out that step that slows all that down, where you have to figure out what the change you want to make even is before you make it. And when you move all of these things into their own classes, I have always seen it be the case that it makes the time it takes for you to figure out what change you need to make longer.
Yeah.
And sure, once you figure it out, it could be like, oh, okay, just change this internal method on this class, and then everything else that calls it works great. Great, that's fine. But if it would have taken you half the time to figure out the change you need to make and then do a global find and replace on the other call sites, was it really better? At a certain scale, it becomes better. At a certain scale, we've sort of become beyond this, where you have these microservices. So there's entire OO programs that are themselves encapsulated in a network boundary that you can't even see into. And at very large organizations, that's just easier. But I don't think that blindly following the single responsibility principle is necessarily a good idea. It's a good thing to keep in mind. I think about this all the time. But it's not. I very rarely write a class where it's that's its only responsibility.
Right. Yeah, I think it's like I mentioned before, it feels a little like utopian, like everything should only do one thing, but like let's be real, to like to do anything substantial, it's pretty unlikely that I don't know, that one. See, now you got me thinking about like files and objects, and I'm all like, I want to say file, but I shouldn't say file because that is not.
But you should. That's what it is.
Yeah, I mean, I guess a file, like there should only be one thing in a file.
Well, sometimes there's not.
Yeah.
So the next one is the open-close principle, which is defined as you should be able to extend a class's behavior without modifying it. And this one is one of my favorites. It's my favorite benefit of doing the super abstract OO style thing. And it sounds like kind of nice to have, just like you were saying, utopian playing. Oh, great. But if I'm writing my own system, open to extension, close to modification, I'm God. I can modify anything. What do I care? Why don't I just modify it? And I encountered this firsthand. So we use Mustache at work for some of the front to share templates between the client and the server. And the server-side implementation of in PHP of Mustache is very OO oriented. Well, object oriented. Very OO. Which, because I had to make changes to it, was a bummer. Because it was kind of difficult to wrap your head around. But if you don't have to make core changes, because it's OO, you can override methods. You can subclass the caching object and override methods to cache how you want. Maybe not on the file system. And as long as you adhere to the interface that is given to you, the surrounding system will use that just fine, which is awesome. There were a ton of examples where we did stuff like that. And it doesn't sound like it gets you any benefits that you wouldn't get from just going in and modifying it yourself. But now we can pull down a new version, and it's, as long as it's not a huge major version increase, it's guaranteed to work. And we can get all the bug fixes and all the new features from open source for free without having to change any of our code. So I am a big fan of open for extension, close for modification. I think it makes things way better. I don't think it's very useful for internal only code. Like if I'm writing a class that I know will only be used at Etsy or at work, I would never think about this, just because it requires more typing and more thinking and more abstraction, which is more time on everyone's part to understand it. But if I'm writing something for the open source community, I would definitely be doing it this way. It's so nice.
Yeah. Yeah. I don't know. I'm trying to think of the last time I did something like this.
It's probably a Laravel sort of thing. Laravel is very adherent to OO stuff.
Yeah, that's probably true. It's probably like that thing I had for Laravel models, like the validation thing. That was kind of cool. And that was I basically extended the save method on models to like first check to validate the data it was trying to put into the database. Yeah, and that was really easy to do because the Laravel models were like really well documented, and like this should return this, and save return to Boolean whether or not it was saved to the database or not. So it was like it didn't validate, return to Boolean. It was great. Yeah, so I that is kind of neat. I think I don't know, like lately. So currently I'm living in like a Backbone JS world. So we have like views that extend crazy things. But one of the things that bums me out about JavaScript sometimes is that there
are no rules. No,
yeah, right. It's the same thing that I used to like a lot about JavaScript. Like I wish there were rules, but not even rules, but just like there's no primitive for describing like an interface.
Yep.
Right. That is not a language feature. Like if you want to say, I have this thing I have this, I don't know, something called a view that is an object with a property called render that contains a function and returns a string. Like there's no way to describe that in the language. And that's like, when you're working with other, like, not having that when you're, just dicking around on your own, it doesn't matter. But when you're working with, like, one or two or 1,000 other people on the same thing, like, that's really useful. Like, that having some explicit declaration some explicit declaration somewhere that says this is what this chunk of code expects, and if you give it to it, it'll work.
So
that's
I have
really valuable.
I have a statement and then I have a question.
Okay.
Statement is Jim Weirich talks about this in the context of Ruby. I don't know if you got that far in the talk. The protocols thing.
Right.
So do you think that applies at all to JavaScript? This idea that just take that object and call render on it, assume that it returns a function, and if it doesn't, then runtime error, and that's as good a guarantee as you can get in a dynamic language that you have an interface, is just to do a runtime error.
Yeah. I mean, maybe it would certainly be better than nothing.
But you don't feel as though you have even that level of. I guess that doesn't. There's no syntactic even in Ruby. There's no place to look to tell you. So if you take write a function that takes in something you're calling a view, you don't know what methods are available on that view, and you only know the number. You can look down the function and see what people have called on it and sort of construct what its properties are, but there could be some you don't know about, or some of those could be erroneous.
Right. Yeah, I mean, I guess, like, runtime validation is better than nothing, but it's, like, in my opinion, it's too late. It's like, it's too late to be useful. Like, I already wasted 10 seconds to refresh my browser to, like, try this again. Like, that's really,
dear.
like, that's something.
Let me introduce you to our 8-minute HHVM compiles.
I'm sorry, but, like, it's so long. And I will say, there are, like, with TypeScript, and I don't know if you've messed around with like Flow.
That was my question for you, is if you feel that Flow, the Facebook static typing for JavaScript, helps this situation at all.
So I think it certainly helps that situation. Like, because I don't know, like, they have an open source Vim plugin that you just download. You start a Flow server, and, like, you write a file, and it type checks it, and it type checks it with all its other, like, all the other files in your project. And it's like, that's pretty compelling. I can write pretty darn close to working code without ever going to my browser, which feels, that's pretty nice. Like, that's something that I feel like that's the sort of thing that, I don't know, like Java developers would like about Java. And having that in JavaScript is totally new to me. That being said, though, I think it sort of encourages, like, kind of Java-ish practices, like, that I'm not sure how I feel about yet.
So you think just static typing puts you down that path?
What do you mean? Like,
because all Flow adds is static typing, right?
Right.
So even just that, you feel, puts you down the Java dark side path.
It's, so I haven't done enough of it to be sure about it. But
was that a thing you used at all when you were at Facebook?
No, it was in the very, like, early stages while I was still there, and it wasn't like really totally useful. Like, it was very beta, if not alpha, like, internally. So I didn't really do it that much, but it's like we did have some constructs for like building in dynamic types to our JavaScript, which was like, again, that was useful, but more often than not, the errors it caught were too late. Like we found errors like in production later that I didn't think of, or came up in a use case that I didn't try because, you know, there are infinitely many use cases. And it was like, it was useful. It was good to know. We saw that stuff in the log, and I could go through and fix it for the next week or whenever. But it wasn't soon enough.
Right.
And I think like I would rather have static typing
than not have static typing.
Yeah, I guess given the choice between static typing and dynamic typing.
Well, so what you're describing is basically type hinting. Really.
Right. Yeah.
Because it doesn't halt execution. And it's a dynamic language, so you can only know at runtime. So when you get this variable in the function, or when we declare this from here, check and see if it's the type I think it is. If it is, not log it. If it is, carry on. That's type hinting.
Yeah. So
this is what PHP does by default, also, or not by default, but you can do that in PHP.
Right. Yeah. And I do enjoy the like static typing world. However, it does like it, at least in the, I guess the explorations I've done on my own, I've like written a bunch of code, and I ended up with like all these classes, and I ended up like with classes
for what programming language specifically?
In JavaScript, like
okay.
So I was doing like JavaScript with Flow, and I ended up with like classes that were simply data containers, which is not something I would, and I was only doing that because it was more convenient than writing out like you can describe in line like an entire object type, like an object structure, but like it was more convenient to write a class in a file that I could share across multiple files. But then I looked back and I was like, oh God, what did I do? Like, like it just felt so unnecessary. And there are other ways to do it. Like you can describe like a types like library that is globally available, but you can't like, it's weird. Like it doesn't export in your package system because it's not really a thing at runtime. It's just nothing. So you have to do that outside of your files, and it's a little strange, but I'm sure like some of that weirdness will be kind of smoothed over as it becomes more mature. But I think, I don't know, at least in my first pass, I stopped doing, or I did less of the kind of functional stuff that I really feel that I should be moving towards to write better and like more maintainable code.
Okay.
And more flexible and useful and easier to understand code.
So you are of the functional programming is a better paradigm for writing maintainable code camp.
I think so, yeah.
Interesting.
That's me.
Cool. Where were we? All right, we're only on number 2 out of 5. Gotta hurry it along here. The Liskov substitution principle, the most haughty named one. Basically, so say we have the view, and we subclass view. The subclass view should be able to be used any place that requires the parent class view. But not necessarily vice versa. So that's the Liskov substitution principle. Is when you subclass a class, you should not make a change that's backwards incompatible with the original class.
Right. Which I think is a very good idea.
Yeah, I think if you're going to be doing inheritance, which is the one I first dropped polymorphism from my favorite parts of OO, and then I dropped inheritance. Inheritance and polymorphism kind of go hand in hand, I guess. Inheritance is one of those, like, to me, real-world programming does not map into a hierarchy.
Right.
So I don't find myself using inheritance all that often. But And what is there a language where you can inherit? Can you inherit like interfaces? Could I just define an interface and then subclass that interface that give it like extend it, basically give it additional methods? But then the Liskov substitution principle would apply any class that implements the subclass interface could be used anywhere the base class interface is required.
Yeah, I think so. I'm pretty sure that's a thing you can do. Maybe not though. I see. Those were the like weird. I rarely got that deep into it.
Mm-hmm.
Like I would sometimes. Well, while I was still at Facebook, I would like. Right now, I'm not writing any Java at all. In JavaScript, like I just do my best to avoid inheritance at all because it just gets messy. Because you don't have like any tools to. You don't have the tools that you have in Java or even in PHP or HHVM or something. Like it's so unstructured that it's just confusing and terrifying. Like it's really quite upsetting in my opinion. So so yeah, I try and avoid it, but yeah. I feel like once you start doing that, like once you start subclassing interfaces and like that's when things start to get cray.
Subclassing, can you even do that? I'm gonna look that up. Keep talking.
I would imagine that is like a language by language thing. But there are some like really I feel like there are some specific like rules about what you can and cannot do there. And then there are also like mix-ins or what are they called in PHP, traits, and then that's a whole other thing. Like the traits can implement the interfaces and classes and
right.
It's madness. It's this hierarchy outside of your hierarchy.
Yeah, and so it's traits in PHP.
Mm-hmm.
Yep, and mix-ins in Ruby. Probably other things. Modules is also something somewhere, I think.
Right.
Yeah, and that stuff is something I like, but it gets really crazy really fast when you have something that has multiple traits.
Mm-hmm.
And I would, yeah, it's nuts.
Yeah.
It sounds like a good idea, but then you're sort of violating the single responsibility principle by dint of even having a second trait on your class.
Right.
Like I can't think of a trait that I would want I want a class to have two different traits.
Yeah. Me either. But in any case, I think in general, like I feel like if you're doing that, like if you're inheriting, like if you have, I don't know, any level of subclassing, I think that is definitely the way to go. I feel like in Java that's like enforced, right? Like you can't have conflicting function signatures, right? I mean, you can have like polymorphic function signatures, but you can't have like the same. Can a subclass have the same like named function with the same args that returns a different value type?
It cannot return a different type.
Right.
But it could do anything inside. It could override the parent class's function any way it wants to.
Right. Interesting.
Which is not just because it returns a type doesn't mean it does the thing that it did before. That's where this Liskov substitution principle comes into play, where you say
I see
it needs to behave if you're overriding something. So did we violate the Liskov substitution principle when we changed caching? No, we didn't, because you say cache this thing and it just cache it. You don't care what it does. Yeah. Moving on, the interface segregation principle. Make fine-grained interfaces that are client-specific. This is one I also wrote down that I liked, but I have already forgotten why I liked it.
Man.
Not sure. Do you know anything about this one, Coley?
No, I'm a little I mean, I think I understand the. I don't know. I'm not sure I understand. I feel like this is like the single responsibility principle, but for interfaces. That's what it sounds like to me.
Could be.
I don't know.
Aha. Oh, this is the duck typing thing.
Oh,
A couple different instrumentation. The most narrow ones almost directly. Ruby offers a lot of flexibility, and its dynamic typing makes a lot of intergrace segregation principles just go away on their own. I mean, right. So I think this is. So what some people do in Ruby is you have a function, it takes something you're calling a view, and then in there they'll do if view, if like not view is a view class, throw an exception. And I think that's a violation of this. I remember this from the talk because you could pass something in that adheres to the protocol of a view, but is not an instance of the view class. And you should be able to do that. But now that you've started to enforce typing in your dynamically typed language, you throw all those benefits out the window.
Right. Yeah, that makes sense. And then like you just cut off like. You cut yourself off from an infinite amount of like flexibility that you could get from having an interface to implement, as opposed to having to subclass a parent.
Yeah, and this is all the benefits that super abstract OO is supposed to get you in a dynamic language. You don't get anymore. Just kind of sad.
Right.
So, the dependency inversion principle.
The last one.
The last one. So, I was wrong. This is actually dependency injection. Yeah, you can tell I didn't get to refresh myself on the last two of this video.
Yeah.
Oh, yeah. Oh, dependency injection. Right. It's my friend. Dependency injection is one of my rules of programming. Always do this. And so a code smell that I have for myself is if I'm looking through a class that I wrote. And I have a deep internal struggle with this. This used to be something I adhered strictly to. Now that I had that experience with everything's a public static method, it's a little bit different because you throw that out if you do the public static style.
Right.
If you're reading through a class and you want to adhere to the dependency inversion principle, you should see no other class names in that class except in the constructor, basically, like except as a type argument, as a type of thing getting passed in. In a dynamic language, though, you should see no class names in that class at all. It should be self or instance variable. And what that allows you to do is test things really easily. Really, I know there are other benefits, but when you like writing tests, and not everyone does, but when you like writing tests, you get so many benefits from this. Instead of having to make an integration test where you go out to your database and write some stuff in because your code, pops open the MySQL driver and starts writing statements. If you pass MySQL in your test, you just pass in a stupid, dumb MySQL class that always returns true for everything, and now your class can just go on its merry way and write all the statements it wants to. And because you don't care if MySQL works, of course that works. You're testing like, what data am I putting into MySQL? Is the SQL that I'm generating correct? So I am a huge fan of dependency inversion, I think. I'm a little bit conflicted, though.
Right. Yeah. So I will say, like, as a plus for JavaScript,
okay.
Let's think about how to word this properly. if you are using some sort of JavaScript module system, be that module system like require.js or like CommonJS, like the Node.js require calls, that is a sort of implicit dependency injection, which is awesome, because then like you do it without thinking, and then that enables things like like you can basically do that without having to jump through the hoops that you have to jump through in Java, because like when you're running your test runner can pass in anything to those as those values to the module loader. It doesn't have to return the real module. It can return a mock or whatever, a mock that you specify.
I think that is what people say when that's what people are talking about when they talk about dependency injection frameworks, which I think like Laravel and a couple of these other things have. It's really just the global registry of these classes that makes calling the class dynamic and not concrete ever.
Right. Which to do in a like not dynamic language, you kind of have to jump through some hoops. But when this like, I mean, it's because modules are not a thing. At least until the next version of JavaScript, modules have never been a language feature. Like it wasn't a language construct, so it's always been like if you wanted to do it, you were doing it yourself with functions, and like clever use of closures basically. So it's pretty sweet. It's kind of neat that happened, because I don't think anyone was thinking that when they came up with like AMD. I don't think that's what they were thinking. Maybe they were, because I'm sure those people are much smarter than I am. But I like to think that it was a happy accident.
Don't be so sure. If there's one thing I've learned, never assume that anyone is actually smarter than you are. Because you will be heartbroken.
Yeah.
Someday you come across a bug.
Right. I guess we all do stupid things.
Yeah, totally true. So what do I'm still really conflicted about Solid. I was really gung-ho about it last spring through summer. But now I'm not so sure. It's like when you read, I don't know, in our teenage years, we read some philosopher thing. I feel like everyone has experience, and then you're like, "Oh, this is the way the world is," just because it's the first time anyone's ever explained it to you. And then later on, you realize, "Oh, actually, no one really knows how this works, and it could be any of these things could be correct."
Right.
I feel like that's where I'm at with OONO. There's definitely some good ideas there. I do not think Java is the right way. I think Erlang is closer to the right way. And that comes back to maybe the immutability aspect also.
Yeah, so I think I put in our mini rundown thing we have, I put a link to like one of my favorite talks ever. I think it's probably the only computer science talk besides the JavaScript WAT talk that I've seen more than once. It's not that I don't like, that I have gone back to and watched again, and I plan to watch again because I am quite certain that I haven't digested all of it.
Okay,
go ahead. No, I want to know. I want to know what
about any of Brett Victor's talks? Have you watched these? He's
I have
on Twitter. Okay,
yeah, that's fair. I also enjoy me some Douglas Crockford talks.
I haven't heard much from Douglas Crockford lately. What is he up to?
He did. He has more stuff. He's done some stuff recently that was less exciting. But it's basically JavaScript. I think his most recent one that I've seen is JavaScript: The Better Parts, and like he stopped using a bunch of stuff that he was using before. Like he doesn't use this anymore, and I don't know. It was classic, like kind of crotchety Douglas Crockford. And he talked about the things in ES6 that he's excited for, and it was like 3 things, and he's like, everything else is a waste of time. Or he didn't say that, but he just didn't mention anything else. But yeah, he's still doing his thing, I think.
Cool.
But in any case, so this talk it's by the his name's Rich Hickey, and he's a guy that wrote Clojure, and continues to work on Clojure, and he works for a company called, I think it's called Cognitech, and they make a database. Sean looks bored. So they make like an immutable database. Besides the point. But in any case, so Rich Hickey wrote Clojure, and Clojure it's like a list-based language that's written in Java. The language itself is actually implemented in Java. It is not just like a JVM language. But in any case, he talks about his talk is called Simple Made Easy, and he basically goes through it and like talks about the distinction between like easy and simple and like complex and hard. And I think like his main premise is that those are things we often construe as the same, like hard and complex are the same, and which is not necessarily the case, right? Something can be simple and also complex. Like you can solve a complex problem in a simple way, and I'm not sure if this is a real word or if a word he kind of like came up with for this, but he comes up with this word that's called complecting, and it's like he says it's like the twist, like when things are twisted together, and he kind of suggests that object-oriented programming is inherently complected because objects are both behavior and state. So like those are 2 things that should not be like are twisted together, and by twisting them together, it is inherently more complex than it should be. So it's like it's a really cool talk, and like I need to watch it like 3 or 4 more times because it's like an hour long and there's a lot going on. And he's like, I think I can say with confidence that he is actually smarter than me. Like he's got some experience and wisdom there that I certainly do not have, having not written my own programming language. So
yet,
yeah, maybe someday. But yeah, it's worth. He has a really interesting perspective, and it's a very intelligent, well thought out, not like snarky in the way that kind of discussions of this sort can be. It's and kind of it is simple but complex, I guess.
Right. Yeah. Cool. So that's Rich Hickey's talk, and it's entitled, where'd it go? Simple Made Easy.
Yeah.
And that was given at Strange Loop a couple of years ago, I think.
Yeah.
Cool. I think that is a great note to end the show on. We have definitely reached time. We got sort of a pseudo pick in there at the end.
Indeed.
I guess I can plug a thing.
Plug it.
Yeah, I know. We haven't had a change mode since I finally wrote that blog post, wherever it is. We'll put this in the show notes. If you go to, I wrote a blog post. I like it a lot. I spent a lot of time on it. Codiscraft.com. And look for engineering rotations. Just talks about some cool, not technical, but sort of meat space stuff I did at work this past year with teaching non-programmers to program in a day and having them push code, which was a lot of fun. So yeah, that's my plug. Thanks. Yeah. Hi, Sean. Yeah, okay. That was a good point. That's what I meant by show notes. I forgot to say changemo.de. That's where you can find it. Any final words, Colby?
No, I think that was a good talk.
Yeah, it was
Like,
fun.
I think that like you said, there are good ideas. Oh God, that was so Rhode Island. Ugh. For shame. For shame. There are good ideas in OOO, and like you can do like anything else, any other programming language or paradigm or whatever. Like you can do great things, and you can write like neat, like understandable code. But I just feel like it's harder. Like it's really hard to create an understandable hierarchy, like an understandable class hierarchy, and like understandable and applicable, like something that is actually applicable to the system you're working on.
Yep, that's what I was going to say.
That's the hard part, and I have been there. Like I've tried to do that, and I've failed spectacularly in every instance. I think so.
So have we all.
Yeah.
Thanks for watching, everyone. It was another great episode of Change Mode, and we'll see you next time. Take care.
This show is brewed fresh weekly by the Coffee and Beer Podcast Network. Get all our shows at our website, coffeeandbeer.tv.